Started off talking about the basic counting principle. Then we talked about permutations, where we said permutations are arrangements. Now we want to talk about combinations. Here we want to focus on NCR, or what we say N choose R. Now this is the number of ways that you can select, the keyword being select, R objects out of N distinct objects without replacement. So NCR or N choose R tells you how many ways can you select R objects out of N distinct objects without replacement. And you will often see that NCR or N choose R is written like this in brackets with NR here. And if we express this in terms of factorial, in terms of factorials, this is N factorial divided by N minus R factorial into R factorial. So like we said, NCR gives us the number of ways we can select R objects out of N distinct objects without replacement. The number of possible selections is called the number of combinations, right? So combinations essentially represent selections, where N choose R tells you number of ways you can select R objects out of N distinct objects without replacement. And the number of these possible selections is called the number of combinations. Permutations represent arrangements, combinations represent selections. Let's look at a couple of examples. The first example is we have 10 people. We want to figure out how many different committees of 3 can we form. So out of 10 people, we want to see how many different ways can we select 3 people, right? So we want to, so here we can use NCR. So this is basically 10 choose 3, which in terms of factorials is 10 factorial divided by 10 minus 3, which is 7 factorial into 3 factorial. What if we wanted to see how many different committees of size 7 can we have? So this will just be 10 choose 7, which in terms of factorials is 10 factorial divided by 10 minus 7, which is 3 factorial into 7 factorial. And you will see this is 10 choose 7 is exactly the same as 10 choose 3. This is not a coincidence. It is a fact that n choose r is the same as n choose n minus r. In this case, 10 choose 3 is the same as 10 choose 10 minus 3, 7. Why? Because see, n choose r means that out of n objects, you're selecting r objects and leaving behind n minus r. N choose n minus r means that out of n, you're selecting n minus r and leaving behind r. In any case, we're dividing the n objects into two groups, one of size r, one of size n minus r. Here you're selecting r, leaving behind n minus r. Here you're selecting n minus r and leaving behind r. But in either case, you're dividing the n objects into two groups, one of size r and one of size n minus r. Doesn't matter where one is, so you get exactly the same answer. So in general, n choose r is the same as n choose n minus r, because in either case, you're dividing it into two groups, r and n minus r. It doesn't matter whether you're choosing r and leaving behind n minus r, or you're choosing n minus r or leaving behind r. So now let's say we have 5 women and 7 men. Let's put another example. So we have these 12 people. We want to pick up a committee of 5. How many ways can we do that? So we know it's 12 choose 5, which in terms of factorials is 12 factorial divided by 12 minus 5, 7 factorial into 5 factorial. What if we want to pick a committee of 5 with 2 women and 3 men? How many ways? So out of the 5 women, we want to see how many ways can we choose 2 women? That's 5 choose 2. Out of the 7 men, how many ways can we choose 3 men? That's 7 choose 3. And since so we know, okay, we can choose 2 women out of 5 women in 5 choose 2 ways, and we can choose 3 men out of 7 men in 7 choose 3 ways. So together, how many different ways can we do this? So here we'll apply the counting principle, because we know we have one experiment which is choosing 2 women out of 5 women, which can be done in 5 choose 2 ways. And then we have another experiment where we're choosing 3 men out of 7 men. This can be done in 7 choose 3 ways. So together, in how many ways can we do them? We can just apply the basic counting principle and multiply them. The first counting principle that we learned, right? So the reason why we're multiplying this is we're applying the basic counting principle to see in how many total ways can we select 2 women and 3 men. So let's look at another part of this. Now we want to still pick a committee of 5 such that one particular person must be chosen on the committee. So total individuals are 12. So now we know there's one particular person that's already chosen on the committee. So if we're choosing a committee of 5, that means that out of the remaining 11, we just need to choose 4. So it's 11 choose 4, because one particular person must be chosen on the committee. So out of the 12, now you have 11 individuals, of which you just need to choose 4. Then they say pick a committee of 5 such that one particular person must be excluded from the committee. So one person has been excluded. So you have total 12 people. You have excluded one particular person. So that leaves behind 11 people. Out of the 11 people, now you will choose 5, right? So the difference between part 3 and part 4 is that in both cases, you're choosing out of 11. But here, that particular person was included in the committee. So instead of 5, you just need to choose 4 now. But in this case, that particular person was excluded from the committee. So out of the remaining 11, you need to choose all 5. So there's a slight difference in the two. So now let's say we want to pick a committee of 5 such that at least one woman should be there. So we have 5 women here and right. So we have 5 women and 7 men. So the way we'll do it, we'll first see the number of selections without any restrictions. So if you don't impose any restrictions, then the number of ways you can select a committee of 5 is 12 choose 5. So let's see number of selections with no woman would be K. We know there's 7 men, 5 women. So you choose all 5 individuals from the men. So 7 choose 5. So number of selections with at least one woman would be number of selections without restrictions minus the number of selections with no woman. This will tell us all those number of committees where you have at least one, right? So if you want to find the number of committees with at least one woman, so we can just subtract those committees that have no woman from all possible committees to get the number of committees with at least one woman. So we have these two more examples where we want to pick a committee of 5 with 2 women and 3 men, but 2 men refuse to be on the same committee. Or we want to pick a committee of 5 with 2 women and 3 men, but one of the men and one of the women refuse to be on the same committee. So there's already another video on this on combinations practice question 1 where a similar example has been done. So this is how we can do combinations. Just keep in mind permutations mean arrangements and combination means selections. And when we use n choose r, it's very important to keep in mind what n choose r is used for. It is used to find the number of ways you can select R objects out of n distinct objects without replacement. And these combinations are essentially, any selections are what we essentially call combinations.